How can two neutral uncharged metal plates pull together in a vacuum, with no batteries and no static clinging? In the energy filament theory, vacuum is the energy C at a local baseline, still carrying tension background noise TBN, and boundaries act as spectrum selectors that change the local pressure of that noise. Textbooks often describe the Casimir effect with 0-point fluctuations, then stop as if naming it was explaining it. In this picture, it's closer to a noise climate problem. Putting two plates far apart and the energy C can support a huge range of ripple patterns between them. Bring the plates very close, nanometers to micrometers, and the gap becomes a strict cavity. Only ripples with the right wavelengths and boundary fits can live inside. Many other modes are simply not allowed in that thin space. Outside the plates, the menu of modes is still much richer. So you end up with a mismatch, more fluctuation pressure outside, less inside. That imbalance pushes the plates together, even though the plates carry no net charge. It's like having a door between a loud room and a quiet room. The loud side pushes harder on average, so the door drifts toward the quiet side. Nothing is pulling from the gap. It's a pressure difference created by mode selection. Mainstream calculations talk about subtracting to infinities to get a finite force. In this language, you don't have to imagine ghost hands. You just accept that the baseline is real, and boundaries sculpt which ripples can exist, so the pressure changes. This is also why the force ramps up brutally as the gap shrinks. It doesn't follow your everyday inverse square intuition, because it's not a two-body field in empty nothingness. It's a boundary sculpted spectrum effect. Change the boundary, change the spectrum, change the force. That immediately explains the practical details people observe. Different materials reflect and absorb differently, so they filter modes differently. Temperature matters because thermal ripples join the menu. Geometry matters because a flat cavity, a sphere plate, and a corrugated surface allow different standing patterns. Put the plates in certain fluids or combine materials with different optical responses, and you can even flip the sign and get repulsion. Use anisotropic materials and the allowed modes depend on direction, so you can get a torque that tries to rotate the plates into alignment. This is not just a philosophy demo, by the way. In micro machines and MEMS devices, Casimir like forces can cause parts to stick, which engineers call stictions. So the empty vacuum starts acting like a real design constraint. If you've seen experiments that obsess over polishing and cleaning, this is why. Real metal surfaces have patch potentials and microscopic roughness, those creating extra forces that can masquerade as Casimir unless you measure and subtract them carefully. There's also a cooler cousin, the dynamic Casimir effect. If you move a mirror fast enough, or rapidly change a circuit's effective boundaries, you are changing the allowed spectrum in time. In this view, that's like shaking the walls of a resonant room so hard that the background noise gets pumped into real, countable photons. But it is not free energy. The energy comes from the work you do to move the boundary or modulate the reflection. So the takeaway is simple: the vacuum isn't empty, and boundaries are not passive. They sculpt what ripples can exist in the energy C, and the resulting pressure difference can push matter around. Next time, we'll connect this vacuum as an active environment to why qubits fight so hard to stay coherent. Tap follow, share it on New Physics, Clear Universe.